And again, without confusing myself and getting too far into this, when you create a variable like this, all you're really doing is it grabs a portion of memory, an address in memory, and it gives it this name. Okay, so it doesn't know when you do this. When I type this line here in the idle shell and hit enter, it's not until you call the variable that it figures out what the type is. So again, this is part of the dynamic binding. It figures out what the type of a variable is at runtime when you actually execute. Okay, so that's that. Here's a cool little program. Let's take a look at this. And you have this. Okay, this is future value calculator. And I'll come down here and say, open, drill down to where it is. And that's not where it is. It is here under programs in the material folder that I gave you. Right, so here's future value. Let's take a look at this. This again is a pretty short program. This first line up here, this is called the shebang line, and somewhere along the line, this pound symbol or hash mark, as you might know it, became the she mark. I'm not sure where that came from, but in the exclamation point is the bang. So that's why this is called the shebang line. Now, what this does, it doesn't do anything to in a Windows environment. Windows, you can write programs without this initial shebang line, but it's good practice to put it in anyway, because I believe in Mac systems, and was that mine? Let me check so I can turn it off. In Mac systems, no, it wasn't mine, somebody else's. Okay, in Mac systems and in Unix systems, you need to put that in there so it knows how to run the program. And I can't tell you much more about it beyond that, but it declares to the program, in this case, that it's a Python version 3 program. Now, Python's got some other peculiarities. Version 3 came along, I guess, 2016 or 2017. It was preceded by version 2. And for whatever reason, unlike other languages that I'm familiar with, notably R, everything is backward compatible. You know, if you write a program in R, if you wrote a program in R 10 years ago and you tried to run it in R today, everything will work with very few exceptions. Sometimes things become deprecated, but it's unusual. Now with Python, when they evolved from version 2 to version 3, all of the version 2 programs no longer run, which I don't understand the rationale for that sort of development strategy. Perhaps they thought 3 was just inherently faster and would be better, and perhaps they thought the advantages would outstrip the cost of having all of the current applications no longer running. And conversely, version 3 programs do not run in a version 2 environment. So there's been enough time, I suppose, that that sort of misstep, stumbling block has been overcome. But within version 3, we're up to release 11, 11.4. Every time there's a new release, they add certain things, and often previous things don't work anymore. But it's a gradual process. Okay, so the shebang line, you want to include that in any programs that you run. This is here. Let's run this, and then we'll look at the code. Okay, so if I run this, it runs within idle. That's the source code, and if you hit run, which you can do here in the menus of the source code, I could say run run module, or I could just hit F5 and it will run it. It runs in the interactive shell. And this is what it does, right? Gives you cute little message. Welcome to the future value calculator. Enter monthly investment. Okay. And so I say, I save $150 a month. Enter yearly interest rate. We'll say 10%, which seems usurious in 2023. And yet 20 years ago, it would have been a bargain. Number of years, 5. And it computes if you invest $150 a month at 10% annual return for 5 years, the future value will be this much. And it gives you this little, do you want to continue? Yes or no? And we'll do one loop. The continue is controlled by a while loop that we'll take a look at in just a second. So we say, let's double our investment, right? So we say 300, and we still say 10%, and we still say 5 years. Now, this should be twice as much, right? The future value should be twice as much. And I believe it is. There's a rounding error. This would round to 72, and that's 71, but we can overlook that. Okay, so get tired of playing with it, and I say no, and it gives us this cutesy little exit message, bye. Let's go back and look at the program. Right, so note it's importing locale. Locale is that module that I referenced that will tell Python what sort of currency symbol to use. Locale is what is causing these dollar signs to print out instead of some other currency symbol. And we're using a set method here, set locale, to fix the currency to be dollars. And we'll talk more about this later. Okay, so print, all print does, let's look at print. Whenever you come up to a function or a data set or just about any object in R that is new to you and you don't know what it does, your friend is help, right? So you can just say help print, and it will. R does this too with the exact same syntax, the exact same word, the help word, right? So print, it gives you the definition of the print is a Python native function. You can also build your own functions, but these are all built in, of course, and it tells you what the arguments are. This means, I believe, that the arguments are optional. You can run a print command just by itself with no arguments. But, or you can use several arguments separated by commas. The separator, this is the default separator, a space between them. And at the end of executing, it will throw a line. This is a escape character, which means throw a line like a carriage return at the end of executing this print function. And I don't know what file and flush does, but again, they all have default values. Okay, and then it describes what the function does. Prints the values to a stream or to sys.dot standard out by default. And then it explains what all of the arguments other than the values that you wanted printed themselves, that's what that one is, and what they do. Okay, so the point of this, whenever you encounter a new built-in function and you want to check it out and figure out what its capabilities are, particularly how you can manipulate it with its own intrinsic arguments, you want to call up help. Very, very helpful. Okay, so what else do we do here? Okay, so notice the use of commented lines. Even though we use the hash symbol up here, generally the hash or the pound symbol is used to put in comments, things that you want a viewer of your program to view, but not to be interpreted or compiled, right? So whenever the interpreter encounters this hash mark, it ignores whatever follows. So you're able to type in your own text explanation about what's going on. And you notice that this simple program, has been organized into different blocks. And when I say block, I just mean a couple of lines of code that are separated by blank lines. And again, that's really for the user's benefit. You could put all these, the interpreter ignores the blank lines. You could run all these together, but it would be more confusing, more difficult to understand what's going on. And also what we have done here is we have put a little description on the top of each block, what's going on, right? So this says display a welcome message, and that's what this does, this little block. This is actually a while loop, and there's no documentation for that, but you could put in something like beginning of while loop. Right. And this while loop actually enables this continue yes, no to work. Okay. So this while, every time the person enters in a while at the end of the program, you'll go through this loop. You go back up here and execute all these lines of code again. Okay. So it's only when you enter no at the end of the program that the statement becomes false and the while loop ends and it exits the program. Okay, but again, you can see what we're doing here now. A couple of things, right? Input. Okay, input is an Python native function that will display whatever the prompt argument for input is to the user, and will stop and wait for the user to type in some sort of interactive input and hit the enter key. Okay, so when we ran the program, right, it said, we printed this out, and then it printed this statement, enter monthly investment. This \T is just a tab. It's an escape character. The \T means put a tab in there, and it's really just used to format it, make it look pretty. One thing you should know about input. Okay, so input it doesn't return this. Input will grab whatever the user enters at the keyboard and will bring that back into the program, and will put that value, whatever the user's value was, into this variable. So when I said 150 and I put enter, it made this variable value 150, monthly _ investment. Now, here's the thing you should try to remember now. Input will always interpret the user's input as text. It will return it as text. So if I want to do some calculations with that number, 150, I need to tell Python that it actually should be a float variable, a real number. So what this does is it changes whatever number the user enters here into a real number instead of text. If I didn't say float, it would create monthly investment as being a text variable with the string or string variable of 150. Okay, so this is soliciting input from the user for the quantity monthly investment. This is soliciting input from the user for the yearly interest rate, which I said was 10%, and then for the number of years, right? We come down here and it just does some simple calculations. Notice because we entered yearly interest rate of 10, in order to get a monthly interest rate, it has to take that number, divide it by 12, which is the number of months in a year, and then subsequently divide it by 100. If I enter 10, the monthly interest rate would be something like 0.0833333333, right? So to get that, you have to take 10 and divide it by 12, but you're still not there yet. You have to turn that into a decimal by dividing by 100.